In this video we'll be going over the continuation of the csharp dotnet tutorials. So in this video we'll be continuing with the notes on on inheritance and polymorphism. So I think this is the second part of that part. So we'll be talking about base class, so the base class and the derived class constructors. So when you create an instance of a derived class, so that means an object, the base class constructor is executed first. So the derived class constructor is next, so every time you create an object. So I'm just going to be on the screen here for a sec. I'm just going to put some notes here. So if you haven't done object-oriented concepts in a while, you probably know this, you maybe just forgot. So it's the same thing in pretty much, I think it's almost every object-oriented programming language, if not all of them. So pretty much, so here we're with, so the base class, which is a superclass. So its constructor is executed first. Oops. Then the derived or subclass is executed second, basically. So when you instantiate an object, so this is when you instantiate an object. When you instantiate an object of a derived class, the base class constructor, the base class or the superclass constructor is executed first. And then the derived class, so then the derived or subclass constructor is executed second. So by default, so if you don't have any constructor, so the default base class parameterless constructor is automatically executed. So you can think of, like, if you don't have a constructor, then it's going to be a paramless constructor with no parameters, and it's just going to execute. First, it's going to get auto-executed by the compiler. That's if you don't have a constructor. So I tried to do inheritance, and the compiler was telling me you need also an empty constructor with no parameters, because I had one that had like 3 parameters, and it was telling me that you also need one without anything, so I just included one without anything. With no parameters and no code inside, I just set a boolean to say like that the paramless constructor is set to true. So you might need that in C#, so we'll just do some examples anyways. So these docs are a little bit confusing on that. They didn't mention that. We're going to look at it in another set of docs, but basically for my professor, he or she didn't really mention whether it was mandatory or not. The compiler was telling me that it was. So if that happens, I'll show you what to do here. So in either case, you can just do this. So you can just, okay, so let's have an example here. Excuse me. So we have a public class here. I'll just say that it's called rectangle. So this is going to be the param list constructor. Param is short for parameter. So to reference the constructor, or to create the constructor, we just reference the class name with some parentheses. So we just go public rectangle like that. Okay. Open parentheses, and remember we're saying that this is parameterless. So in this case we don't put any parameters here. Usually we would say like maybe we have an int size or something. But in this case we don't include any parameters. We're just going to open the block like that. And you don't really need to put anything in here. What I did is if it doesn't work, because in some languages it might not compile, but what you can do is you can just say that you can have like private bool param list constructor set points to false, and here you can just say param list constructor points to true. This should work. It compiled for me. Yeah, so this should work. Notice how we're not passing any parameters in here. We're just directly referencing the field here without passing anything into the object when it's instantiated. We're just saying that this boolean is set to true in this case, that the constructor was set. Because sometimes if you just have no code inside, it may not execute. I think in C it might work. In Java it might not. I can't remember. But some languages might not. So you can always just try it. Okay, so here we'll have another one. So we're going to overload it here. Then here we'll say, for example, just the same thing, public, and then rectangle. We can say that takes like a int size. Int length, int width, string color or something. And here we could say that we want to just set those fields like we know how to do from the previous videos. Okay, so that's pretty much it. This is our base class. This is the base class here, superclass. So now we'll do the other class, the subclass. Okay, so we can pretend that it's in another file. So we can say public class. Remember to do inheritance in C#, use the colon, like that. We could have done shape and then rectangle. My professor did this. I'm just going to do this way because I already started, or I'm just going to name it this. We'll just call it box, and we'll say that it is a rectangle. Because boxes are usually rectangles. If it's not a perfectly square box, but you get the idea. We could have changed that to square, doesn't really matter. So we could pretend that box is a rectangle, because when you see this operator here, the colon operator, you can just say that, you can replace it with isa. So you can say, because you can think of the subclass that has a isa relationship with the base class, you can say that public class box is a rectangle, but instead you can say that, but what's really happening is public class box is inheriting from rectangle. So public class box inherits from, I say inherits from, that's fine, whatever you want to say. So public class box inherits from rectangle, then here we'll say private, we'll have a field here. Int, we'll have a backing field, so we'll say height. Then we can have our parameter list constructor here. We could set the boolean again like last time. Then here we could overload the constructor like this again. We could say that it takes an int length. Uh, that's pretty much it. So we could just leave it like that, actually. Okay, or we could just, yeah, just like that. That's pretty much it for the first part. Okay, so constructor issues and inheritance. If you want a parameterized constructor in the base class to execute, or so if you want to, basically if you want a constructor here in this base class and the superclass to execute, you can just overload them like this. So when you instantiate the object, it's going to know by the signature of the object or whatever. So whatever parameters that you enter into the object, it's going to match it. So if you enter 3 parameters that's the same types as this, it'll go with this constructor. If you enter no parameters, it's just going to match with this constructor. Okay, so if the base class does not have a parameterless constructor, okay, so this is the thing in C#. So if the base class does not have a parameterless constructor, you have to use the base keyword. So we'll probably discuss this in a sec. I have a feeling my professor's notes are kind of off here. So we have base class. No, sorry, not base class. We have base keyword. It's a reserved word in C#. Okay, so I think this might be a little off. But pretty much it's like, okay, so if the base class does not have a parameterless constructor, you must explicitly call the base class's parameterized constructor using the base keyword. Okay. So you just call base. I think there's an error here, so we're just going to skip this for now. We'll come back to this later on when I look at the other docs. So pretty much, let's just move on from here. So constructor issues and inheritance. So we could pretend that we're instantiating something. So we could go with, for example, we could say that we're going to create a box here. We'll say box points a new box. So we're going to instantiate an object like normal. We'll pass in something here like that. Okay, so we're instantiating a box. Nothing too hard. So pretty much we'll be moving on to polymorphism now. So we'll come back to this stuff later on. So we'll be discussing more about pretty much this inheritance. So we'll just go get into just an intro to polymorphism basically. So we'll just say, for example, polymorphism. Actually, sorry, we'll go below this base keyword. Okay, so the term polymorphism refers to an object's ability to take different forms. So you can think of something morphing I don't know if you've heard this example before, but for example, I'm sure you've heard maybe like the term morph, like something morphing into something else. You may have heard it at some point. It's not like a common word. Things don't morph too often, but you've probably heard of it. So that's where it comes from. So basically refers to an object's ability to take different forms. So it allows derived classes to have methods with the same names as methods in their base classes. So it refers to an object's ability to take different forms. It allows derived classes to have methods with the same names as methods as their base classes. So we'll just note that down here. It allows derived classes to have methods with the same names as methods in their base classes. Okay, so next note is it gives the ability. So it gives the ability for a program to call the correct method. Oops, sorry, I have some spelling mistakes here. It gives the ability for a program to call the correct method. So depending on the type of object that is used to call it. So it gives the ability for a program to call the correct method depending on the type of object that is used to call it. So it's a little tricky. This is one of the trickier concepts in, what's it called? Inheritance and all that. Basically, when you're using derived classes, this is more of the trickier concept. It's not impossible, but it's just a little tricky. So obviously the theories aren't going to make sense until we do the examples. So we'll just talk about the example, a little bit more of the theory first. So when a derived class inherits from a base class, it gains all the methods, fields, properties, and events of the base class. So we know that. So to change the data and behavior of a base class, you have an option to override a virtual base member, so you can override things. Okay, so this is called ingredients of polymorphism. Basically what you need to cook it. So these docs identify two essential ingredients of polymorphic behavior. The ability to define a method in a base class. Okay, so let's just note this down here. So the ability to define a method in a base class, and then define a method with the same name in a derived class. Okay, so the ability, sorry, I'm not sure if you can see that, hopefully you can. So the ability to define a method in a base class and then define a method with the same name in the derived class. So in this case, the derived class overrides the base class. Overrides the base class method. The ability to call the correct version of an overridden method depending on the type of the object that is used to call it. Okay, so the first one is this. Up here, the one that we already did. the ability to define a method in a base class and then define a method with the same name. In a derived class, the derived class overrides the base class method. So the second part is the ability to call the corrected version of an overridden method. So the ability to call the correct version of an overridden method depending on the type of object it is used to call it. So if a derived class object is used to call an overridden method. So if a derived class object is used to call an overridden method, then the derived class's version is the one that executes. If a base class object is used to call an overridden method, then the base class's version is the one that executes. So it just depends on the object, really. Okay, so it's a little bit different in C# versus Java. So the keyword, I think when I learned Java polymorphism and inheritance, you've seen me use it in the data structure videos, maybe some of the other Java videos if you're following that stuff on my channel, in those playlists. But pretty much I don't think I actually did the full codes on them. I may have done some of the theories, maybe some notes on it. But pretty much, so there's another keyword in C#, it's called virtual. So the keyword virtual. So the keyword virtual is used to declare that a derived class the keyword virtual is used to declare that a derived class is allowed to override a method of a base class. So here we can have an example, so we'll just say example here, whatever this is. So we'll say that we'll go back to the animal class. So the animal class here, we can say that we have a private string local field, or local backing field. Private string species, we can say that here we have a constructor. And it takes a parameter, so string, it takes a string species. And here we can say that we want to reference the backing field, point it to the parameter. So the backing field is going to point to the parameter. Okay, so so we have our animal class here. We have the constructor that takes a parameter string species. And here we're saying that the backing field species points to the parameter species. So then here we'll have the property, so the constructor's done, so we'll create the property. So we'll say public species, so public species like that. We'll open a block. We're just going to actually just leave it empty because we know how to do that. Okay, so for this part, we're going to say public virtual void. So you have to call virtual before, so in the definition of the method, So here, public virtual, we'll call it that it's just sound, or whatever the animal makes a sound. Then we can basically derive this. For example, this allows the derived class to override it. It's a little tricky. We'll do some examples, some actual examples coming up. This is just a half example. Then we know how to create an object of a class. So here we just call, for example, animal. Once a new animal. Here we pass in the constructor. We can say that the species is a snake or something like that. And that's it. Remember, it takes a string species. So it's a little tricky. We'll be continuing with that in the next video. So we'll be continuing with the rest, probably just a little bit more of the intro to the polymorphism notes. And we'll move on to some code examples, some real ones. So thanks for watching, guys. If you guys like the video, you can like and subscribe to support the channel for more programming and investing tutorials. So the rest of the videos are going to be in the csharp.net playlist on my channel. Thanks for watching. I'll see you guys in the next one. Take care. Thanks.